Okay, as a follow-up to a previous video, I just wanted to show you this short video, which is a nice physical demonstration of the stability limits on floating objects. As I mentioned, we're not going to cover the detailed mathematical analysis of floating stability in this course. That's a more advanced topic for ship designers and naval architects. But I just wanted to show you this demonstration of the main concept of stability since we covered it in a previous video. As I discussed in a previous video, you start by tipping the boat through a small angle, theta. This analysis assumes the boat is symmetrical about the vertical center line, so the weight acts at the center of mass on the center line of the boat. Now for a floating object, the weight is exactly balanced by the buoyancy force. Recall that the buoyancy force acts at the centroid of the displaced volume. That's the cross-hatched area. And I think you can see because the boat is tipped, the buoyancy force shifts to the left. As you can see, there's more displaced volume on the left side of the center line of the boat. Now you follow the buoyancy force up to the line of symmetry of the boat, and where the buoyancy force intersects the center line is called the metacenter. By the way, for small angles, you can show that the metacenter is independent of the tilt angle. As we discussed in a previous video, if the metacenter is above the center of mass, then the boat is stable. That's because the moment produced by the weight and buoyancy forces is opposite to the direction of the initial tilt, so the boat will tend to right itself. Okay, let me start the video so you can see this in action. So here I think you can see that this is the situation where the weight is below the metacenter and the boat is stable. And even if you raise the weight, it's still below the metacenter in this situation, and the boat is stable. But eventually, if you raise the weight enough, the weight moves above the metacenter, and the moment produced by the weight and the buoyancy force act in the same direction as the initial tilt, overturning the boat. In a real situation, you could easily imagine a small boat tipping over in this way because, for example, everyone went to the upper deck at the same time. And that completes this video.